Okay, and we are live. Hello. Thank you for making it to the sixth meeting of the High School SlimSat Space Initiative 26. This is associated with the CAPE-Twiggs CubeSat program. We are out of the University of Louisiana at Lafayette, and our main project team who assembled our proposal to CSLI includes Dr. Paul Darby out of our university. He's the principal investigator. We have Mr. Bob Twiggs, who is the co-inventor of the CubeSat, among other things. We have Mr. Nick Pugh, who's here in the lab with us. He's our electrical mentor and wealth of innovation. We have Miss Melissa Poore as well out of Bishop O'Connell High School, who is in the trenches of education along with everybody else here, I'm sure, at whatever level you're participating in education. And we may go ahead and get started. So today, it's been a long time. It's been a long time since we met together. So welcome back to our meetings. This meeting, our intention is to just give everybody a recap of our mission, where we stand, and also get some information from you so that we can be prepared to share SlimSat modules with you so you can have the experience. So, first and foremost, our mission is the CAPE-Twiggs CubeSat mission. This mission exists to get SlimSats into the hands of you, you at your school and your mentors. This is our current version of a SlimSat. We will ship these out to everybody, at least 20 schools who wants one. And the intention is to get this on a CubeSat so that you can be a part of a satellite mission. And we want this to be the next generation of educational space exploration. And this comes from the CubeSat in general. The CubeSat is a form of satellite that was invented in the 1900s by Bob Twiggs and his partners out of California. And it is designed so that it fits inside of a deployer easily. All of them can fit inside of a deployer. And as long as that deployer is on a rocket, we can shoot a bunch of them out into space all at one time. Since the invention of this, thousands have been launched. Thousands have been launched for all different purposes: educational, science, military. They're easy to build, relatively speaking, and to launch. Our lab here at CAPE, we have been participating in this with Mr. Nick Pugh and our faculty and students for about 20 years. We launched our first one in 2007, I believe. Following that, we launched our second CubeSat, CAPE-2. This is just an engineering model of it. Then we launched CAPE-3. Following that, we launched CAPE-4, which was a 3U satellite. So these guys are 1U satellites. Our CAPE-4, which hasn't been launched but is in development, is going to be a 3U. I don't have that sitting by me right now, but CAPE-Twiggs, which is our mission, educational in nature, is also going to be a 3U. It's designed so that SlimSats can go inside of it and get launched. This is an example of a mechanical engineering capstone project at our university. They were tasked with designing a 3U for the CAPE-Twiggs CubeSat project to eject SlimSat modules. And so they put an Acme Rod in the center of this CubeSat, put some rails on the inside of the CubeSat, and they put a motor in the tuna can so that the SlimSats would ride along this rod as they were deployed. We've had other opportunities. Our lab helped Melissa Poore participate in a hyperbolic flight where we used some of Claire Toya's 3D design to make this 1.5U CubeSat. And it flew on a zero-G flight with Miss Melissa Poor to observe the behavior of the SlimSats as they were ejected into space. It worked. The mission was a success, and we deployed SlimSats remotely from this module, and we got to observe them in a zero-G environment. I believe a couple more participants in our project are slotted to have another zero-G flight this year. And so we also have a concept model from Mr. Bob Twiggs on the CAPE-Twiggs CubeSat. Now, this is a 1U model, and it just demonstrates SlimSat modules inside of a CubeSat form factor with our rails and the SlimSats on the inside. So far, where we're at, we have a prototype SlimSat that we are flushing out and fervently trying to populate and build and get ready to disseminate so everybody can participate and have one and run experiments in their classroom. But we can't get those SlimSats into space unless we have a 3U satellite to put them inside of. At the moment, we have four versions of this 3U satellite. One of them was developed originally by Mr. Bob Twiggs, and we call it the toaster method. And the idea here is that our 3U satellite, once it's deployed from the CubeSat deployer mounted on a launch vehicle, and it is in orbit, it will deploy SlimSats one at a time in a toaster-like method. So you see a SlimSat right here made out of wood, a SlimSat here, and a SlimSat here. And they're held inside of the 3U with fishing line, and resistors will heat up, cut the fishing line, and then launch a SlimSat into space. Another version that we have is one that we already talked about, and I showed you guys, where our SlimSats are on an Acme rod or some sort of rod, and as it rotates, our SlimSats are ejected. And you can see there are differences here. We have to launch these sequentially, whereas if we have a toaster method, we can launch whichever SlimSat we want to first. We have another method which was designed in our laboratory by Mia Reyes, which is it's called a vending machine method, where our SlimSats sit inside of a spiral, and that spiral rotates and they are pushed out. I don't have that sitting in front of me right now. It's around here somewhere. And then our third method was designed in Miss Poor's lab, in Miss Poor's room, with a belt-driven drive by one of her students. I believe it was Ella. Is that right? Yeah, Ella. And so the SlimSats sit inside of the 3U, and they are deployed with a belt drive. And the SlimSats sit on the belt drive, and the belt, pushes the SlimSats out. So we haven't decided on 3U deployment method yet, but these four are on the table, and we welcome any other ideas and designs and contributions to this process. So that's where we're at right now. I want to thank everybody for being here. And for now, I will hand the meeting over to Miss Melissa Poor to talk to you about science and space and things like that. Melissa?
Awesome. All right, I got it. I hope you're hearing me okay.
We can hear you, yep.
So I do have several of our satellite teams sitting in here with me, including Ella, but I do want to hold up yet another module. This is module 2. It is a replica of the one that Garth held up that was flown on a parabolic flight. So I want to talk to you all briefly about physical models and doing this as a beginning step this year to start out the curiosity, the exploration, bring on some new teams, new team members. By making this out of cardboard and with cardboard pieces as your satellites, to get the size, the fit and form, and just this idea in their hands. So I do want to say that our satellite slice we're calling Space Toast, and we love this system that we've been working on so long, and we love to describe it to people in a way they can understand, which is talking about having it be about the size of a loaf of bread. Each piece is about like the size of a piece of bread. And definitely we will be testing all of these in a thermal vac testing situation. But we will have burnt toast once we fly and we have a nice time in orbit. And then these clean up themselves in space because they're so small. So we're excited to propel the CubeSat design further. And I just wanted to make that point, Garth, that we were challenged by NASA and the CSLI team when we got this grant to do something extra than our original design, and that was to have controlled launches. So this is exciting, everyone. This is a well-known satellite design. It is used by industry all the time. And the point, though, is the experience for academic institutions needs to be the first fit for this kind of experiment. Our satellite models in history are usually built by NASA. They're much, much larger, maybe the size of a car or something, and they're doing more capabilities than our satellites will do. However, the launching and deployment system is very complex, and this is super advanced. So I do want to add these two elements to our team challenges to make a prototype model of the 3U in cardboard, and then multiple slices inside so your students can get an idea of what it would take to push these out. So get familiar with CubeSat form, get familiar with the current deployer push plate. So we created just one plate with 4 springs on the back, and that has been our favorite model to show other people so they can understand the concept of design. And yes, so launcher challenge has been exciting and being part of making a big change in space. So let's have our teams develop mission patches. I know that if you're a returning team, you've already heard this before. We have a beautiful start of a design for our whole CAPE team. We have a beautiful logo that we want to share with you. And let's get into how I think that we all should be starting. We want to explore. We want to be excited. We want to ask the hard questions. How can we make our satellite do something different when it's ejecting? So imagining a big design. However, that is a strategy that is very advanced, and the collaboration between the university and our school is the only way we were able to do the electronic part. So no matter what skill level your campus is at, we are excited to provide scalable activities that include basic sensors like the weather sensors and sharing our familiarity on that. But also there will be opportunity to have your own hardware component on this as well. So if you're able to do some background research to understand what can we measure above us, what do we care about in our local area? Are we by a river? Are we by a railroad? Do we have hills? A big excitement for our summer team that we worked with and my current team are fluctuations in weather that are drastic. And through research, we found out that states use balloons and they launch them every 12 hours. And that data is the best data they can use to predict on-ground weather scenarios. So one of the first challenges you will have is doing that very experiment on the ground with your hardware and on a tethered balloon. But to get your students excited, I developed a series of lessons that I thought would be just a good shell to put around this, which is the history of satellite development, how the United States has contributed as compared to others, and then how academic institutions are using satellites to learn. And I think that my favorite part about this is that I'm able to link with mentors and colleagues in other areas and advance my learning and my students' learning without leaving my school. So yes, Garth, I think you were talking about something about having our network and being more available to each other. That is what I'm looking forward to this year, is having more talk time between teams and involving our students at the meetings. And we're also looking for you to share something great that you've done with this. Like maybe you had a one meeting and there was some outcome that other teams would like to try. I know that I think I see one of the people I wanted to talk about. I don't see her on right now, so I want to save that for when she joins. But she did work with 2 different balloons to prepare her students with procedures. And she wanted to share about the success of that. And she is, 2 of our people do have a really cool ticket, a ride to do some microgravity tests. And I can't wait for all of us to make our mark on the satellite industry through education satellites. All right, so yeah, so Garth, I'm going to kick back to you for now to go on to the next part of our agenda.
Sure. So just a couple of things to note. We've been talking about mission patches. This is, if you can see that, that's CSLI mission patch from CSLI, okay? This is a mission patch from Alana, which is closely related to CSLI, the Educational Launch of Nanosatellites. That's what Alana is. CSLI is the CubeSat Launch Initiative. That's who we submitted our proposal to acquire a launch. This is a Bishop O'Connell CAPE-Twiggs Space Toast mission patch. So we would like every team to have their own mission patch if they could, if they have creative enough people to do so. So that's one thing. And another thing is we've had our meetings so far since the beginning of this year. And I have been inviting everybody via blank carbon copy. And so that's to protect everybody's information. I don't want anybody, so that's why I've been doing that. However, today I'm going to send out a registration form of sorts for teams to fill out. And it asks just for 11 basic things. And actually, I'm going to show you this form right now. Just give me 1 second while I get it pulled up. Okay. Can we see this? Yes, okay. So this is our CAPE-Twiggs CubeSat, which is the name of our mission, High School SlimSat Space Initiative 26. That's the name of the program we are all participating in at the moment, and that your school will participate in. And we'd like you to fill this out in order to receive a SlimSat module in the future and for participating. We will also use this information to forward you an agreement from our university as far as using the SlimSat module goes. I believe everybody here, most people here have done ITAR training, and so that is what that's for. But we'll send you an agreement. It's no big deal, but we need you to fill that out so we can send you a SlimSat module. So this is the form we'd like you to fill out. It asks you what your team name is. We already have some team names. It asks you who your mentor is, your mentor's first name, mentor's last name, their email address, which we likely already have, and also the students on the team. This one we will fill out. Each student will get their own line and just put their first name, last name, and if they would like to share their email address, they can, but we don't require that. So that way we can keep them in the loop as well. And we can give them access to the materials as well. We ask you for a mailing address, and so this is for the SlimSat module to go to. We ask you what your school or institution is. We ask you where it's located, and then we ask you what your biggest science question is. Be that what's the air pressure in low Earth orbit, or are there aliens in space? It doesn't matter. And we want this question to just drive your space experimentation and exploration. We will have another question on there right here somewhere at the end with questions, comments, or concerns. So we will get that out for everybody after this meeting. And we ask that you fill that out so we have all of our teams in one finite location, and it will be official.
Garth, I would like
Yeah.
to add that I have been exchanging emails with a few of the teams, and
Yeah.
I know that they're looking forward to seeing some of the milestones and work in short form to share with their students. So I will have that for our next meeting, that we'll send that in an email in between. And we can send a link to our resources again that are the lesson modules. So if this is your first time joining the mission, we started in January, we went to May, and this is our first meeting of this school year. We started in January by rolling out a different activity each month. But what I would like to tell you is that we're going to give you access to all of them. I think it was like 5 to 8 activities, but they did cover the use of platforms that are sponsored by Jet Propulsion Lab. Also a really cool space trash app. And I've been really lucky to be working with that developer continuously on advancements on the app. So I'm excited to do one of our meetings on that one, and that is the Wayfinder app. But the other ones are meant to be documents that you can use with your team, printables, an internet scavenger hunt on satellites, the history of satellites, a look around the deep space mission that is run through JPL, but for all of NASA, that provides basically the Wi-Fi for the universe. And that's what we're really getting at, is the data that we're collecting is also used for navigation, deep space type data. It's all very similar system, and using the CubeSat to teach from has been a really cool way to teach all of those concepts. So I would love to hear if anyone would like to see a resource in a certain area, or if there's a topic you'd like to hear about again. We have our special team that has so much experience that we want them to share often, but we also want to provide moments to hear from each other. So Garth, didn't we agree we're going to work on having more conversational meetings where we can hear from teams for part of the meeting? Now that we are deep in and getting ready to share the hardware. All right,
Yeah.
so
Yeah, so
question?
in the form, there's a question if you are willing to share your information with other teams. And that's kind of so we can turn on the CAPE-Twiggs CubeSat network. We have a lot of people who have been participating. And we'd just like to ask you your permission to share your information with the rest of the team and the rest of the team your information so that we can collaborate together. Also, whenever you fill out this registration form, we are going to give you access to part of our Google Drive. We have a folder made for you guys. And as you register, we will make a folder just for you, and it will have your team name. And this is where you can specifically work out of. And also, this is where we're going to store public information for you guys. For instance, Claire Toya has CAD files for this right here that she developed. And she has a whole video. We dedicated one of our meetings to her designing this. And you can go back and check that out on our YouTube channel, which is where we post this. Like and subscribe. I'm just kidding. But that's where this will be. So you can get this, and Ms. Poor mentioned the previous educational materials about the Deep Space Network, Wayfinder. Those things will also be in that folder. So that's another thing. So what we have is registration form. We'll send that out. Design a mission patch if you are so creatively inclined, and also build a cardboard CubeSat and think about the science question. All right. Well, thank you everybody for being here. We'll go ahead and adjourn the meeting, and we'll be in touch via email, and see you next month for our next meeting. Bye-bye.
Thanks, everyone. Good night.